Hello, Professor. I am Yug. This is my project. Let's discuss the unsafe part of my project first. I have two folders in my submission, unsafe and safe. So you can simultaneously watch both of the parts together. So let's start with the unsafe code. So I'm using SQLite, Flask, and then we have this populate table function, which creates the table if not present, deletes any existing tables, deletes any existing records, and puts these three sample records inside the table for the attacker to attack on. And then we have this index route, which is the home page. We have this register user route, which inserts the values. And as we can see here, this string interpolation is the unsafe way that we are attempting, which allows a SQL injection to pass. And then we have this execute script function, which allows multiple SQL injections to be executed within one go, which is also vulnerable to SQL injection, since we know that SQL injections bypass the valid SQL query and execute a malicious SQL query afterwards. And we have this login route, which is for login, again string interpolation, which is unsafe. And then we have this welcome route, which is seen after successful login, and then there's this logout route. Great, let's view how the project works. Oops, I went safe. Okay, let's go to port 777. The first attack I wanna do is to change password of one of these three persons, right? Let's change Lennis's password. So let's update registration info, set password equals bad, where name equals Lennis, and everything else is commented out. Let's see if this works. Cool, it does not, because we have no such column as name, because our column is named username, where username is Lennis. Okay, Lennis's password has been changed to bad, which is a SQL injection. Our second injection is to bypass the login system. So let's bypass the login for a genuine user. Let's bypass Yug's login. So, to bypass that, we will be using this particular string as the password. So let's do that. Space or space 1 equals 1 space comment login. Great. So as we can see here, welcome Yug, but the password that Yug enrolled with is something else. So it's not really Yug's password. Hence, this is a security vulnerability, and we can log out. And the last query we want to discuss is to drop all that existing data, right? So let's go back to registration. Let's go to none and let's drop this table. So drop table registration info and then comment everything that comes after it. And as soon as we click this, we get an error which says no such table registration info, because at the so in our index page we always keep displaying the existing users, right? So since there are no existing users, there is no table to query. We are getting this particular error, which means our site has broken. Great. So this was the unsafe part of the code. Now let's understand how we have made this code safe. So let me start the file. Oh wait, I started the unsafe one again. Let's go to the safe directory. Okay, so similar setup as before. The password, however, this time is hashed using SHA SHA-256, and address is encrypted using AES. We will just see this in the code right now. So we are using regex, we are using SQLite 3 hashlib, we are using environment files, uh, environment variables, we are using AES cipher from crypto library, then we are using secrets for random token generation, and then flask again. So the changes here that is that we are reading a secret key from a file, we are hashing the password, this is hash password, this is encrypt function. We are not really using decrypt function here because we don't want to decrypt and show the, so here we are decrypting the address column, but we don't want to decrypt the address column and show it to anyone, hence we are not implementing decrypt here. So again we have the populate table. However, the difference here would be that we are reading the passwords from the environment file, and then this is how we are calling the encrypt function. While we are calling encrypt, there are these side variables called tag and nonce. Nonce is number only used once, which we don't really need for any kind of computation in our project, so we would be skipping those. Next so this is just insert, and let's see what we have next. So this function is the same as before, it just displays whatever lies in the current database. Next, so the next major change here is that we have these regex patterns for username, password, address, and fun fact, and these are backend input validations which would be occurring before inputting the data into the database. So, and here we are matching their matching the strings with their corresponding regex patterns, and if they do not match, we return invalid username and do not proceed further. And here we hash the password, encrypt the address, and then our insertion data consists of hash password and encrypted address. And if everything goes well, this 4 tuple gets inserted into the database. Coming to the login route, it is pretty much the same as before. However, yes, one more difference that we have here is that we are using the execute function here, which only allows one SQL query to be executed at a time. This would prevent a lot of SQL injections which rely on executing at least 2 injections one after the other, right? Next, we want to talk about yep. So here we are addressing the login vulnerability which occurs during login, and next we just check if user is found. We put username and hash password in session, and then we have the SQLite error handler function, we have welcome same as before, and we have logout. Cool, let's see if our old injections work anymore. So attacker, we have password as attack, we have address as none, and we have update table registration, update registration info, set password equals bad where name equals, let's do change Nick's password and comment everything later. Cool. So if we click registered, it says invalid password format. So our password format was, if we see, it's going to be 3 to 20 characters of small, uppercase, lowercase numbers and hyphen, full stop and underscore. So let's try to provide a valid username. So let's say I provided a good amount of lowercase, uppercase numbers, and let's give it an underscore. So let's see if this works. Okay, invalid address format. What is the address format? We need upper lowercase letters, numbers, hash, forward slash. Okay, let's provide it a valid address as well. Invalid fun fact format. Now this is where the attack is really happening. So we have isolated this field, and if the attacker is a genuine person and really wants to register, he has to get rid of all these discrepancies in the fun fact field. Cool, so this did not work. Let's check if the login vulnerability is still working or not. So attacker, and so remember we were discussing about if this particular string is going to give us access. So let's provide this string here. So space or space 1 equals 1 and then space, comment everything. Great, object of type none type has no length. Okay, so let's see. Oh, my bad. So yes, we don't have any user called attacker, right? So we would have to genuinely try to use someone else's account. So let's try again. Space. Okay, let's. Yes, so we have figured out the issue. The issue was that we were not returning an error when we did not find when we occurred a new when we saw a bad login. So let's try it once more. So we have the username Yug, and we, let's say the password is again this particular query, right? So let's enter that 1 equals 1, and then you have comment everything out. So wrong password for user Yug. Let's try the same for Lennis, and let's try to bypass Lennis's account. So if we want to do that, or 1 equals 1 space comment wrong password for user Lennis. Well, so the attacker cannot bypass anyone's account login now. So let's try with our last query, which is the drop table query. So if we do that, we again get invalid fun fact format. This is just the regex patterns helping us out and not further executing the code. So this is how we have implemented SQL injections. Thank you.